Just see now to our maths, looking at completing the square, okay, grade 9 only, higher tier only for AQA, EdXL and OCR, okay, in roughly 96 seconds. Let's go. So this is 2i. Show that x squared minus 8x plus everything that shares is greater than 0 for all values of x. Okay, so to actually prove that, guys, I've got to actually complete the square here. To obviously prove here that that is obviously going to be bigger than 0. So I'm going to have x, and then it's going to be minus, and then it's going to be half the coefficient of x. So that'll be 4, so x minus 4, and then I'm going to square there, put it in the brackets, and I'm going to square it. Then I'm going to subtract the square of this, so minus 4 squared, which will be 16, okay, and then plus 17, okay. Now simplifying this here by collecting like our terms here, our numbers here, I'm going to have x subtract 4 all squared plus 1. Okay, now from here we can clearly see that this will always be greater than 0, and the reason for that is even when x is equal to 4, so 4 subtract 4, that'll be 0. 0 squared is 0, plus 1 is going to be 1, so this will always be bigger than 0. In fact, this will always equal a minimum of the number 1, if not higher. Okay, so this quadratic does not actually have any real distinct solutions here. So yeah, graphically it actually looks something like this here. So it's a bit more of a weird one actually here. So it looks something like this, okay, roughly, yeah, and the minimum point here would be 4, 1, okay, or yeah, your turning point, okay, or the minimum point on the quadratic, okay, yeah, so it's the opposite sign here, yeah, so the coordinates of the turning point here, or the minimum point, would be 4 and then 1 here, 4 positive 1. Okay, it's the opposite to the sign in here for your x coordinate, and then your y coordinate is just that part there. Okay, so that is what your quadratic looks like actually. So actually, yeah, that actually has no real distinct solutions. Yeah, so hence why it looks like that. Okay, so that is our answer for part I. Okay, so hopefully it makes sense. Okay, so I've completed the square there. So that's how we do completing the square, guys. Okay. For part II, okay, if I add if I add 3 to a number and then square the sum, the result is always going to be bigger than the square of the original number. Okay, state, given a reason, if the statement is always true, some's true, or never true. So if I have 3 plus x, let's see here, so my number is x, and I square the sum, okay, is that going to be bigger than the number squared? So in this case here, x squared, okay, so x is just equal to a number in this case, okay. So if I expand and simplify this, I'm going to have 9 plus 3x plus 3x, that'll be 6x when I expand here. So it's a double bracket expansion, and I'm going to have plus x squared, okay, is greater than x squared. If I now subtract x squared here on both sides on my inequality here to obviously balance it respectively, I'm going to have as follows. I'm going to have 9 plus 6x, okay, is greater than 0. Okay, and even here, yeah, I can just actually stop here. So I can clearly see, okay, that when x is greater than minus 9/6, okay, that will always be true, okay, so that will always be true here when you have that inequality, okay. So yeah, so yeah, that one actually, so that one is actually sometimes true. Initially you might be thinking, well, hang on a second here, like if I like add 3 to like a number here and then actually square it here, that will always be bigger than the number squared. Well, if I have, let's say x was equal to, I don't know, -5, let's say, okay, or -2, let's say, then you'd have like 3 subtract 2, okay, yeah, if x was equal to -2, yeah, and then is that bigger than -2 squared? Well, no, that's not true, because that becomes 1, so I have 1 squared is bigger than -2 squared, so that'll be 4, so 1 is bigger than 4, so that is not true. So this is sometimes true, guys, yeah, so this is sometimes true, okay, this is true, okay, only if, so if and only, or only, yeah, if x is greater than minus 9/6, okay, or minus 1.5, is that right? Yeah, minus 1.5. Okay, so when x is greater than minus 1.5 or minus 1.5, then that is true. Okay, so that's my answer for that question. Okay, yeah, sorry for going a bit over that shit, but hopefully it makes sense. Okay, but that's how to answer that question. So this is actually from an AS pure mathematics paper for the edXL spec, but this kind of question here is appropriate for higher tier grade 8, grade 9 students here. So students that are aiming for that grade 9, this video will be appropriate for you. Okay, and also yeah, like grade 7 students as well. Okay, thanks for watching, and I'll see you in the next one. Okay, bye for now. Take care, all the best. Okay, and this video is also appropriate, of course, here for Gcse further maths here, AQA level 2 further maths, and also yeah, AS pure maths here, and obviously A2 pure maths as well here. So this is also appropriate for A level maths students as well. Okay, so just actually clarified. Thanks for watching. I'll see you in the next one. Okay, bye for now. Take care, all the best.